Hello everyone. So yes, my name is Roman. Does this work? Nice. And I work with Tunda and Babel at Belmont. We built this new bank. It's this new internet banking written in ReasonML, and we're using React, obviously. And actually, at this time, we also have Next under the hood. So. Tonda actually mentioned a couple of times that our app crashed because of no reason. He didn't mean this reason, just to clarify. Second? Oh yeah, the test. And this just crashed. So this just crashed for no reason. Can I ask you for the next slide? I didn't know how to approach this talk very well, but I think I need to talk a bit about how I got to Reason, because this talk is not go and use Reason. I actually think that Reason is much harder than JavaScript, in terms like, okay, so if you know JavaScript, TypeScript isn't that hard, you just add types. But going into Reason, I think it's important to, count with some new ideas and more functional approaches to things and whatnot. Can I ask you for the next slide, please, sir? Yeah, I started with C. That was the previous slide. That was like me doing some, terminal applications, and then I shifted to. It takes quite a lot of time to build an app in a terminal, with C, like without UI libraries and whatnot. So I shifted very quickly into C#, which is this thing. Does anyone know this? So this is what you use to build Windows forms, and you use .NET for this. You kind of have like a list of components on the left, and then it always happens. And you drag the component into the canvas, and then you edit props down here, which is kind of like React in a way, but there are lots of ornaments in your code. Like what I mean by that, you write a lot of code before you actually write anything functional. Like public override void something return something. Like that's not a functional code. That's just that's those ornaments. Next slide, please. Why does it not work? Oh yeah, I started and then I shifted to PHP, and I was doing eShops. And then it occurred to me, like, I want my apps to be more interactive. Like this filter at the center, it's like I don't want to, whenever I'm filtering products, I don't want the site to refresh, whenever you click. So I was just like reloading the content. So I learned how Ajax works, and I was like, okay, this is JavaScript, and can I learn more JavaScript? Next slide, please. And so I wanted to learn more JavaScript, and I moved to London and started working for this company where I could still like utilize my skills in PHP and learn more JavaScript. So I started working for a company called Evanstagram. Can I ask for the next slide? And yeah, next one. Jesus, this is not gonna work. And I think you need to press it once more in order to play. But this was like a company that was like, we were scraping photos of Instagram and Twitter and making like real-time slideshows out of it. So it was very, up to the point where I was like, I want to learn JavaScript, how to build one interactive one. So I was building these kind of slideshows. They were written in like WebGL, JavaScript, Canvas, Angular, jQuery, you name it. Can I ask for the next slide, please? Just trying to quickly go through it. Next one, there'll be Angular logo, that's where I started, because this is like the year 2013 or something, or 12, I don't know when, actually I don't remember when Angular came out. Next slide, please. And then React came in, and React came in with, next one, this doesn't work, sorry, it's embarrassing. And React came with this, and this was interesting because it was like mixing HTML and JavaScript all together. So it felt like, there were some people hating it, some people were like, oh, this actually makes sense. And this comes from a language called XHP. Next slide, please. And XHP actually looks like this, and it's just the same thing for PHP. And So yeah, this made all the sense from now on, right? Because people are used to it, and but we were at the time I was still like approaching things from the PHP side of things, and the C# side of things, which was very like OP, and it was quite painful to write a class in JavaScript because like you had to know how the prototype works, how binding works, in order to create an object or instance of an object. So we were using CoffeeScript for it because you could use this class, extend something, and then next slide please. And then at some point I gave up in that company and I moved on, and because I was just tired of building site shows, and I actually found this new company called like Red Badger, and I started at one of their projects, and it all looked like similar, and I was like, okay, I don't know this. Why do they use like these ads? And I didn't even realize I'm writing LiveScript, because I was writing CoffeeScript before. LiveScript was nice because it was more functional. It had this like pipes, scope things, like this arrow. Like next slide please. I need to fly through this, and then. Or like pipes again, I'll get to the pipes later, but like LiveScript its idea was like, less code, more work done. That was the idea of it. And then Babel came out. Babel used to be called, it used to be called 625, but you could actually write, the new ES6 stuff and compile it back down to ES5. Next slide, please. And then React came with functional components. Next one. There's many slides. And then flow type came in, and that was very interesting because like we could start building our apps in a more safe way, And so we were started. I was still back on that project which was started with LiveScript, but we had to kind of shift into the new Babel way of doing things, and with flow type on. So there are quite some funny stories. For example, we had to pay our there was like probably 6 teams of developers based on 6 teams of 5 to 6 developers. So it was like 30 developers across the company, and we had to kind of migrate the LiveScript into the new Babel and flow type stuff. But nobody wanted to do it. So can you go back? So we had to pay them in terms of like we were like giving up bottle of wine every week. So who is gonna transpile most of the files? And some guy actually came up with a code mod that would take the LiveScript and convert it down to Babel, JSXify it, and you still had to do some work like fix some imports, whatever. But next slide. And then we started looking at TypeScript and that was I was back in Prague. This is like 4 years forward, and then here in Prague we actually we introduced the flow type as well. But at some point we were like, flow type is dead, and everybody seems to be doing TypeScript. We're like, okay, let's do TypeScript. And fun thing about this transition was that I actually felt like I'm writing types most of my day rather than functional code again. Like these ornaments that I was speaking about when you're doing C#. There's a lot of ornaments, and I feel the same way about TypeScript. I still think it's a great tool. It's trying to solve a problem that Reason has actually solved 20 years ago, because like Reason, when I talk about Reason is actually OCaml language, and as I was talking about flow type and this transition between flow type and TypeScript, flow type is written in OCaml. It still hasn't solved this issue with like safe JavaScript application, but I think it got much further just because of better inference of types. So you kind of write less types with flow type than TypeScript, and I think this is still true today, but I haven't been looking at flow type recently. Because I'm all down to Reason now. Anyway, can I ask you for the next slide? And then hooks came out, and this is like this is basically, that's without TypeScript. Anyway, next slide. And now we are doing this reason in the company, and this is how it looks like. This is like a very simple component. You can see that it's almost like JavaScript, apart from that props. Those props have like a tilde in front of them, which means they are named arguments rather than an object. And named arguments are basically very helpful when you want to have one of them optional and whatnot in usual functions, not just components. Like this works across the language, which gets me to next slide. And so what is React? Like I think React is like you could see that React is just like I think it's just a set of principles and ideas which are really good, and they make you gotta like click this through while I go because there's like a few steps. Oh yeah, like React is now like most popular JavaScript UI library. Like this is based on the state of JavaScript from last year, where people say like 63 of JavaScript developers are actually using React, which sounds good. Next slide, please. And those principles are like, first one is obviously composition. Like it should be fairly easy to introduce a new state to our application without changing anything else. Like for example, it should be very easy to introduce new state to a component by introducing local state to it and not affecting anything else out of it. So this is probably the main principle of React, and it goes down to functional composition. Like whatever. Next one, please. Then immutability. That's another one. Immutability helps very a lot with understanding your application, because if you know that variable is immutable, it's obviously easier to reason about it. Like what's gonna happen in your app and whatnot. Next one, please. There's like three more that I'm not gonna dive into because I don't. Yeah, escape hatches are really important. Like for example, this is how React works with the. Like React gives you this abstraction on top of DOM, this declarative way of writing your application. But if you somehow need to, touch the DOM node or like do anything with it, you still can via refs. So this is like the use ref in React. That would be the escape hatch there. And next one, please. And then obviously there's like stability and gradual adoption that those guys were talking about. And some interoperability, some interop. So which means how do you communicate with the outside world again? Like can you introduce React? Can you just introduce one React component in your Angular component? That's very important to have. Like otherwise, those principles and ideas wouldn't be adoptable across the company. And next one. And then there are those approaches to understanding. Just press it double times. Oh, that was too much. And like first one is via testing, and the second one is via informal reasoning, which is basically based on those principles and ideas that simplify the reasoning about your application, and that's very important. Like this is like there's actually a new reason. There was a reason conference in Chicago this year, and Jordan Walk has the talk about React, and he's the author of React. And he asked people like, what do they think about React? Like, how do they work with it? And what he said is, React actually made my work fun again. And what they mean by that is basically it really simplifies the way how they think about their applications. They understand them, from top to bottom, because they are based on these principles. It's really like important to keep it simple. Next one, please. So what is Reason? Reason actually takes those ideas from React and it brings it to the language level. And it's also just a syntax and toolchain for OCaml, which means that it reuses its like 20 years old type knowledge that those guys invested into OCaml. So it has really good inference. Next one. It's created by the author of React, which is Jordan Woke. You should follow that guy if you know more. If you want to know more about React. Next one. It has native support for JSX. You don't need Babel or anything. It's like it's basically in the language. Next one. And it has amazing developer productivity, which I'll get to by the end of the talk. What I mean by that is like the number one thing about Reason is like refactoring story. It's like because you have no types, it's super easy to refactor it. Next one, please. And it has pre-tier built in called reformat. It's another one. So you basically just install one tool and you get all of these for free, rather than like installing Babel, TypeScript, or whatever, what have you. Next one, please. Oh yeah, 20 years of type theory behind. It's basically just a new syntax. That's what I mean by it's a tool chain for OCaml. It has a couple different things on top. But yeah, next one, please. Oh yeah, don't ask me about this slide. This is from this is from a MOOC which is like a course for OCaml, and they say that like these are the core principles of OCaml. Yeah, I'll get to the the polymorphic types and type inference. That's probably the most important one, because that's the one that lets you not write types but still have your code base type safe. And first class functions, they obviously are in JavaScript as well, but like here you get autocurring out of the box. Like for those that know Ramda, that has autocurring, but here you have it like out of the box and type safe. Because Ramda is super hard to type, as far as I know. And then like algebraic data types and pattern matching, which is something I'll get to later. Can I ask you for the next one? Oh yeah, and it's also cross-platform, which is like OCaml is a system language. Reason is a system language. So you basically pick the like the target platform and use a certain compiler that will target those platforms. This one is, for example, a project called Reverie, and it's something like Flutter. Does anyone know Flutter here? Basically, you write your code once and you compile it down to web or native. It's supposed to replace Electron one day. It's not that far away, and also like they still have a long way to go. But like it works on the basis just like Flutter. It compiles to OpenGL or WebGL on the web. They could probably change it from WebGL to using DOM nodes. Actually, that's not that hard. But yeah, next slide, please. And so, who uses Reason? So all Messenger is yeah, raise our hands. So all of Messenger is written into Reason. Now and some other things as well. Next one, please. Then there's like a slide of Bloomberg. That's where Reason. Half of the Reason was created, which is called BackleScript. I don't want to complicate things too much, but because they'll merge those two together soon, hopefully. But like BackleScript is the compiler that targets JavaScript platform. And then they use it at Citrix for some Unicode stuff. And I really find the third one interesting, like where they actually take some C code and they analyze it with OCaml to find out whether the C code is safe, because it's like for some flight, controlling machine, whatever. And then at Facebook, obviously, they use it for the float type and PHP type checkers. And Microsoft uses for drivers validation, apparently. And the other interesting one is Darklang, which I don't want to dive into right now, but yeah, you go next slide. And this is my favorite quote from the OCaml MOOC, which is the OCaml course. I'll just let you read it, but basically, this is how our development looks like on daily basis. Like one of those reasons I think that we have time to mess around with testing and whatnot is because we use Reason. Like we don't spend time writing TypeScripts, and whatnot. Next one, please. So what does it look like? This is like more, the first one was very simple component. This is a little bit more advanced, but it's still stateless. And it looks just like JavaScript, apart from you have at the top, on top of a function, you have like something, it's called annotation. And it uses something called PPX under the hood, which basically generates code. I have like another example of this later. But there are no types here. And also, it's still 100% type safe. The other thing is, what happens with your components and like utility functions or anything in JavaScript, it's like when you write a module like this, which is like a component, at the top you usually have like import. I call this wall of imports. And you can go to, I don't know, 20 of them, and then you have like 5 lines of functional code. Just reusing all those functions that you imported and whatnot. There are no imports in Reason. Like, you can open modules, but like, yeah, I find it really nice that you can just ask for, amount format module without importing it. What else? I had something about this in there. Anyway, next slide, please. And it has some readable JS output. So on the left you have Reason code, and on the right it's actually the JS output for this for these lines. So it's basically, it's quite readable. So if you need to debug, you have an idea of what's going on in there, and it's not being very cryptic. And they are continually improving this. Next one, please. And this is the pattern matching I was mentioning. So like the school person, that's like an algebraic type. And I want to say, like I said that there are no types in Reason, and there obviously are some. I mean, you can write them if you want. But what this one is, I would split them in two actually. Like the first one, they are abstract. You don't know about them. You can just like use the values, and the compiler makes sure you're using them correctly. And also then there is a second one, a second kind of type, and that would be domain types, which is something like this, where you actually use them to drive your code development. It's actually called, they call it type-driven development. So that there's the actual word. So this is the Reason version. If you go next, if you want to do something same thing in TypeScript, and to have it like type safe 100%, which means that this switch case that previous switch case was exhaustive, which means that if I omit some value, it'll tell me you forgot this type of value. You can do the same in Reason TypeScript, but it's like those ones where 8 lines of code. This is 30, so it's less code to manage as well. If you go to the next slide, I believe I have their version of a Fantasyland for JavaScript. If you are happy with runtime errors only, you can use this. And this is something called like catamorphism, which is some Greek word, whatever. But it's the same thing. It's still the same thing. Next one, please. And then like function composition, which looks like this in JavaScript. Nobody wants to read this, so next one. So, there was there not a slide? Oh, this one. So you do this, right? You use pipe from Lambda or like Lodash, whatever. The problem with this is that pipe is actually really hard to type. You have to you cannot type it as far as I know until like even today without like typing and restricting it up to some number of arguments. You then have to combine pipe with pipe, and that's how you go around with it. But yeah, next slide. With Reason, you can just use pipes like Mario, which is the weird syntax on the arrow. The first one is basically the same example as before. This one is actually from our code base. So you can do like flat map, all the functional stuff that you like. And next one, please. And at the beginning I was mentioning C, and C is really good at being fast. And like the compiler for Reason is fast as well. So this is just a video how much time it takes for us to build the whole app from scratch. Like we are probably over 800 modules now. This is not correct, but still, it's probably still like I don't know 5-10 times faster than TypeScript. It takes like 8 seconds. And if you go to next one. This is the incremental build time, which is even faster. That was the build from scratch, and now if you are actually working on something, for example here, my QA asked me, hey, I'm missing a test ID somewhere, so I'm just going to find the place and add the test ID there. I need to, name it properly, so I'll probably delete it before. And save it, and you see it took 100 milliseconds basically. So that's like the incremental build time. So you can iterate very quickly. And if you go to next slide, I believe there will be, okay, GraphQL PPX, that's another video. Basically, does anyone know GraphQL here? Everyone, awesome. So you write queries within the code base, like you see the percentage GraphQL, that's the PPX I was talking about. Like it's basically a Babel inside your code base, but typed again. Like it's typed. So you can write whatever you want here. And did it play? Does it not play? Okay, whatever. It'll basically tell you that the field doesn't exist there because it knows about the schema, it checks whether you're using it correctly or not. And if you go to the next one, then it will generate you a module, and if you use it again in incorrect way, it will tell you you're using the result. But there are no types anywhere. They are generated. They are abstract, as I mentioned. And yeah, if you go next, I think we are finishing soon. This is another PPX. We use this one for forms. Because we have like custom abstraction on top of forming, which we might change soon actually. But it uses lenses PPX, which will take this state and will generate. If you go to the next slide, you'll see the generated code. So it generates more of this, and we use this for having super type safe form abstraction. So there are no strings anywhere. So when you do I want input of this name. You can't use the name because it'll tell you, it shouldn't be a string, it should be a variant. And the value needs to be of that type and whatnot. And next slide is probably the last one. Oh yeah, if you want to know more about Reason, we sometimes do ReasonML meetups in Prague. And the next one will be in January, which will be led by Tonda. Because he has some ideas. So if you want to know more, we usually do dojos where you can bring your own computer and write some code in Reason, and we help you to do it. Next one, please. That's it. Thank you very much.
Any questions?
Why do you want to switch from forming and abstraction to it?
Because it doesn't let us define our state of the form in a way that it wouldn't be impossible, to initiate. Have you heard about making impossible states impossible? There's a great talk about this, where you can avoid writing many tests just by defining your state properly. And when you have these algebraic data types, it's very simple to do so. So that's why.
I actually have one question: how we deal with some browser APIs if you need to?
So our login page can't use anything from third party. So that's completely written in pure Reason. And we just use bindings to native DOM API, where we just mess around. I mean, we do DOM manipulation like you used to do in jQuery. It's fun. I mean, it's not, but
I mean, like some geolocation or whatever.
Oh yeah, you just write bindings. That was one of those like escape hatches I was talking about. You just write bindings to the third-party stuff that you want. Like you can do this not just for JavaScript, but you write bindings to like C library and whatever.
Your core application is type safe, so it's probably safe even on a runtime, but then you have that binding which can.
Yeah, you could mess up the binding.
Yeah.
Yeah, that's where the usually like where the bugs come from. We have still one section of our like internet banking written in, and I believe we still receive most runtime errors from that one. That's that one in TypeScript. But yeah, that's just I don't know. I don't even know if it's true anymore. But
Good. Any question? If not, thank you very much again.